In this lecture, we will discuss the classification of systems, and we already discussed linear system and nonlinear classification in the previous lectures. Now we'll discuss the time invariant and time varying property of a system. And in the first lecture, we will discuss the definition and the basic steps to find to check the linearity properties, not linearity, time invariant property, and later we will do some problems. Coming to the definition part, a system, it can be a continuous time system or a discrete time system, is said to be time invariant. For example, assume that the input of this particular system is x of t and the corresponding output is y of t. And the system is said to be time invariant. Okay, time invariant. If a time shift in the input signal, that is, we are providing a shift in the input signal, that is x of t minus t0, and if the system is a time invariant system, an identical time shift in the output signal means if the input is x of t, the corresponding output is y of t. And if it is a time invariant system, so time invariant system, for the input x of t minus t0, you will get an output which is simply the shifted version of the output y of t minus t0. So this is not true for all the systems. This condition or this property is valid only if the system is a time invariant. Okay, so this is a mathematical notation to indicate a time invariant property, and this is a basic definition. So we can repeat the statement: a system is time invariant, okay, if the shift in the input signal leads to an identical shift in the output signal. And another important property point regarding this time invariant, or we can state the time invariant property in another way, that is the characteristics of a time invariant system do not change with time. Means if you are getting an output, for example, this is an amplifier, and assume that for this particular amplifier, we are applying a sinusoidal signal with amplitude 1 and minus 1. Today, we are applying the sinusoidal signal and we are getting output with a gain of 10. Okay, so this is the case. And if you perform the operation on the same system, okay, on the next day, and if you are applying the same signal, okay, and we are getting the same output. And from this example, you can say that the characteristics of the time invariant system do not change with time. So we are getting the same output irrespective of the time. If you apply sinusoidal signal with 1 volt as a maximum amplitude, you are getting an output of a sinusoidal signal with a 10 volt maximum. So we can say that this particular amplifier is a time invariant system. But practically, this is not true. There will be slight difference in the output because the components used, the resistor, the transistor, and all temperature dependent. So with respect to temperature, all these values may vary. Okay, but on an ideal case, an amplifier, we can call it as an ideal case. Okay, if the parameters are not changing, we can call it as an amplifier is a time invariant system. We will get the exactly same output irrespective of the time. But practically, it's not true. So most of the systems are time invariant systems, and ideal systems are, we can call it as a time invariant system, but all other systems are, we can call it as a time varying system, either so time varying or time invariant. Okay, that you should invariant or not, and also use the word varying. Okay, so don't confuse with this. Invariant means not varying. Okay, not varying. And now we can describe the same definition in a mathematical way. We already mentioned that for a particular system, for a discrete time system, this is a discrete time system, and the input of the discrete time system is x of n. So here you can see that this is the system and the input is x of n and the corresponding output is y of n. And if that particular system is a time invariant system, then for the input x of n minus n0, this time invariant system will produce an output y of n minus n0. The same concept is valid for a continuous time system also. So if the input is x of t and the corresponding output is y of t, and for this particular system, for the input x of t minus t0, it will produce an output y of t minus t0. And one more thing, the definition time invariance is slightly different in the case of discrete time system. In some textbook, you can see that instead of this time invariance, they will indicate the shift invariance. Okay. In discrete time system, the x-axis instead of time they will indicating some numbers. So that's why they are using this shift invariant property. Okay, either you can expect a question from time invariant or shift invariance. Okay, I think the definition part is clear. Now we'll move to some questions. Okay, first we can discuss a continuous time system, and for this particular system, as a continuous time system, we need to verify whether the given system is a time invariant system or not. So here the input signal is x of t and the corresponding signal is y of t. And this y of t, if you are applying an input x of t, the corresponding output will be t into x of t. So that's the behavior of the system. Now we can check the time invariance property. So actually we need to perform two operations. That is, first we need to apply an input x of t minus t0, then we need to find the output, and after that we need to find out y of t minus, what will be y of t minus t0. So in step 1 we will find what will be the output if you apply x of t minus t0. That is, we will apply for a particular system. So this is step 1, and assume that for the input x of t, the system produces an output that is y of t. And now, and this y of t is written by t into x of t. Now in step 1, we will apply an input that is x1 of t, which is simply the shifted version of the input signal, that is x of t minus t0. And assume that for the input x1 of t, the corresponding output is y1 of t, and we will find what is y1 of t if you apply x1 of t. So you can write y1 of t is equal to t into x1 of t, and in place of x1 of t you can substitute x of t minus t0. So you will get t into x of t minus t0, and this is equation number 1. So in the first step we will apply a shifted version of the input signal, that is x of t minus t0, that we can call it as x1 of t. So now we got the corresponding output that we can indicate it as y1 of t. Now we will directly find what is y of, that is step 2. In step 2 we will find what is y of t minus t0, because we know the output equation. So here it is y of t is given by t into x of t. So by using this particular equation, I can find out what will be the output at t minus t0. So simply you can replace t with t minus t0. Then you will get output at t minus t0. So for that, I can simply replace t with t minus 0. So that's the difference. In the first case, we will apply a shifted version of the input. That is, we will apply x of t minus t0 to the system. We will apply the input x of t minus t0, and we will find the output. So in this particular case, that is y1 of t, and we got some expression for this, that is t into x of t minus t0. In the second case, actually we know the system response, that is for the input x of t, the system response is y of t. Now we'll find the output when t is tending to t minus t0, or the output is shifted. Output is shifted to t minus t0. So in order to find the shifted version of the output, that is y of t minus t0, you can simply replace t with t minus 0. So in this particular equation, we will substitute t minus t0. So here also t, so we need to replace t with t minus t0, and in place of t, so actually 2, you need to change t with t minus t0 and x of t minus t0. So this is equation number 2. So now we got y of t minus t0 and the output corresponding to x of t minus t0. And if you compare these two equations, so you can see that these two equations are different, or you can say y not 1 not equal to 2, or you can say that y1 of t not equal to y of t minus t0. So from this example, we can conclude that the given system is a time varying system. Time varying system, or we can call it as a not a time invariant system. So by checking this particular property, you can conclude that this equation number 1 and 2 are not equal. So the given system is a time varying system. So with respect to time, the output will change. Or we can call it as a not a time invariant system. So don't confuse by the representation time invariant or time varying system. Not a time invariant system or a time varying system. You can use either this statement or this particular statement. Both statement indicate the same concept. You can say time varying system or not a time invariant system. Okay, I'll give you more idea about this particular problem. For this problem, assume that on a graphical way I can explain this particular problem. For example, assume that y of t is equal to t into x of t, and assume that x of t is a step signal u of t. Okay, assume that is u of t, and graphically u of t means is a step signal, and which exists from 0 onwards, which is equal to 1, and this is a t axis. Now the signal y of t is equal to t into x of t. Okay, y of t is equal to t into x of t, in this particular case t into u of t. You can plot like this, ramp signal which starts from 0 onwards. So when it is 1, the output is 1. When the output is t axis t 2, the output is also 2. So this is a signal y of t. Okay, t into u of t, because the signal t means, it simply t means if time axis is 1, the signal amplitude is 1. If time axis 2, signal amplitude is 2. If time axis is -1, signal amplitude is -1. So you'll get a straight line passing through the origin with slope 1. And t into u of t means you will get a signal only to the right side. Okay, that's the difference. This is t and this is this is t and this is u of t, and this is t into u of t. Okay. Now we can apply a shifted version of the signal. That is here x of t is equal to u of t. Now in step 1, we will apply a shifted version of the signal, that is x of t minus t0. That is u of t minus t0. If u of t minus t0 will be a time shifted version of the step signal, or you can write u of t minus t0 is equal to 1 for t minus t0 greater than 0, or you can say t greater than t0, and 0 for t less than t0. So assume that this is the point t0. From t0 onwards, the signal amplitude is 1. That is u of t minus t0. Now, if you are applying the signal x of t minus t0, u of y1 of t can be written as t into x of t minus t0, that is t into u of t minus t0. Okay. If t0 is 2, the signal starts from 2 onwards. So the resultant signal you can plot like this. This is t. Already the signal t means something similar to this, and if it is t0, from t0 onwards there is a ramp signal. Okay, so that's a meaning. So at this particular region, signal amplitude is 0. That is actually t into u of t minus t0. This is the dotted line is actually indicating t, but if you multiply the t into u of t minus 0, t0 will exist only from t0 onwards. So from this particular point onwards, u of t minus t0 exists. So this is a signal y1 of t, or t into u of t minus t0. In steps 2, so we got the output when input signal is shifted. Now we can directly find the output signal by shifting. So this is t into u of t. Okay, so this is signal t into u of t. If you shift the entire signal towards t0, okay, if you find y of t minus t0, it becomes t minus t0 into u of t minus t0. It's x of t minus t0. In place of x, you can substitute u. It becomes t minus t0 into u of t minus t0. It's simply the shifted version of this particular signal. Okay, so you will get a signal which is entirely shifted from t0 onwards. So this is a signal t minus t0 into u of t minus t0. So see the difference. So here you can see the signal shape. The two outputs are different. So the same problem I just explained in a graphical way to get a clear idea. Okay, this is actually the time invariance concept. So here you can see that if both signal starts from t0 onwards, or both signal shape is same, we can call it as a time invariant system. But unfortunately, this is a time varying system. Okay. So you don't want to draw the graph or exam point of view. You can explain by using the mathematical equations. This is only to understand the concept. Okay, now we'll see another problem. So here it is given y of t is equal to e raised to x of t. So we need to verify whether the given system is time invariant or not. So for that, you can rewrite the equation y of t is equal to e raised to x of t. Now we need to perform two steps, because we need to verify the output for the shifted version of input x of t minus t0. So first we will apply the input x of t minus t0, and we will find the output. Okay, assume that x1 of t be the input, and x1 of t means a shifted version of the input signal. So that is x of t minus t0, and the corresponding output is y1 of t. Then you can write e into x1 of t. Okay, in place of x1 of t, you can write x of t minus t0, because x1 of t is shifted version of the input signal. So this is equation number 1. Now in step 2, you can find the output at t minus t0. That's a shifted version of the output. This is the shifted version of the input. Now we can find y of t minus t0. So in this particular equation, you can substitute t by replacing t with t minus t0. So you'll get e raised to x of t minus t0. So this is equation number 2. And if you compare equation number 1 and 2, 1 equal to 2. That is, if you apply an input x of t minus t0, you are getting a shifted version of the output. So we can conclude that the given system is a time invariant system. Invariant system. Okay. Time invariant system. Now we'll do next question. Here y of t is given by x of t into cos t. Again, in step 1, we will apply an input x of t minus t0. That is, we can consider an input x1 of t, which is a shifted version of the input x of t minus t0. And if we apply this particular input to the system, the output will be y1 of t, and y1 of t is equal to x1 of t into cos t, because we are applying an input signal. So this is the input part, and that is x1 of t. And if you replace this x1 with x of t minus t0 into cos t. So we don't want to change this t, because if you apply any signal x of t, output will be simply the product of cos t into x of t. So x of t is the input. Cos t is a factor which is provided by the system. Okay. Now we are shifting the input signal, means we are shifting x of t. So there is no change for cos t. Okay. This is equation number 1. And in step 2, we are applying a shifted version of the, we'll find the shifted version of the output. That is, we'll change t with t minus t0. So at that time, the equation becomes, simply replace t with t0 in the given equation. So it becomes x of t minus t0 into cos t minus t0. So the concept is different. In the first step, we are applying a shifted version of the input. Input means is only x of t, not t. Okay. In the second case, we are shifting the entire signal. So we will replace each t with t minus t0. So this is the second part. And if you compare these two signal, equation 1 and 2, they are not equal. So we can call it as a time varying system. It's a time varying system. Okay. Now we'll discuss another question. Here it is given as y of t is equal to cos x of t. So previously we explained the cos t, now it is cos x of t. And in step 1, we will apply a signal x1 of t, which is a shifted version of the input signal x of t minus t0. And we will apply the shifted version of the input to the system, and we will find the output, and we'll call that output as y1 of t. In place of x of t, you can substitute x1 of t, or you can write cos x of t minus t0. Okay. This is equation number 1. And in step 2, we will find the shifted version of the output. That is, we will change t with t minus t0 in the given equation. So y of t minus t0 becomes cos x of t minus t0. So in place of t, we will substitute t minus t0. And if you compare these two equations, equation number 1 and 2 are equal. So we can call it as a time invariant system. The given system is a time invariant system. Now we'll discuss this particular question. Here, this y of t is given by the equation x square of t. And in step 1, we will apply an input x1 of t, which is a shifted version of the input, that is x of t minus t0, and we will find the output. Let the corresponding output is y1 of t, and in place of x square of t, we'll substitute x1 square of t. Okay, and x1 of t is actually a shifted version of the input signal. That's we will change. We will apply a shift in the input signal. So this is the input signal. So it becomes x1 of t minus x square of t minus t0. This is equation number 1. And in step 2, we'll find the shifted version of the output. That is, we will replace t with t minus t0. So in the given equation becomes y of t minus t0 into x square of t minus t0. If we compare the equation number 1 and 2, they are equal. 1 and 2 are equal. So we can conclude that the given system is a time invariant system. Now we'll discuss a slightly modified version of the previous question. Y of t is equal to x of t square. So here you can see that square is given to the time. Okay. So please compare with the previous problem. In the previous problem, it is x square of t. Now it is x t square. And in step 1, we are going to apply an input x1 of t, which is actually the shifted version of the input signal. Okay, we are shifting x of t by t0 unit. That's the meaning. Okay, and the corresponding output you can assume that is y1 of t, and you can substitute x1, so it becomes x1 of t square. Okay, now we can find the y1 of t in terms of x of t. It's simply x of t square minus t0. Okay, so there can be a confusion that how will you write this. So for the problem solving, always remember that we are shifting the input signal. So apply the shift t0 to the given signal which contain x of t. Okay, so this is x of t square. Simply shift that signal. That is x of t square minus t0. That's a shifted version of the signal x of t square minus t0. Don't simply replace with t minus t0. That we will perform in step 2. In step 2, we will change t with t minus t0, or we will find output at t equal to t minus t0. It's a shifted version of the output. So the given equation becomes, in the second step, we will change t with t0, t minus t0. So it becomes y of t minus t0 into x of, in place of t, we will write t minus t0. So it becomes t minus t0 the whole square. See the difference. In the first case, we are shifting the input signal. So whatever given in the system equation, simply in place of x of something, simply put as minus t0, only minus t0. In step 2, in order to find a shifted version of the output, simply replace t with t minus t0. So if you expand this, we can see that these two equations are not same. This is 1 and this is equation number 2. And if we compare equation number 1 and 2, they are not equal. So we can conclude that the given system is a time varying system. So whenever a question comes, some transformation in time, okay, make sure that in the first step we are simply shifting minus t0, and in the second step we are replacing t with t minus t0. So that's the difference. We'll see one more problem. So here you can see that again y of t is given by x of 2t. Okay, so in step 1 we will apply an input x1 of t, which is simply the shifted version of the input, that is x of t minus t0, and the corresponding output is y1 of t. Then you can write x1 of 2t, and x1 of 2t becomes the shifted version of the input signal, that is x of t minus t0, that's minus t0. So only concentrate on this particular portion. So you can simply write x of 2t minus t0. Don't replace t with t minus t0. The given signal is shifted. So the shift portion is minus t0. So only apply shift on the given signal. So here y1 of t is x of 2t minus t0. This is equation number 1. And in step 2, we will write or we'll find the shifted version of the output. That is, output is y of t minus t0. The shifted version of output is y of t minus t0. The given equation is y of t is equal to x of 2t. So in this particular equation, we will replace t with t minus t0. That's the difference. Here x of 2 into t minus t0. So if you compare these two equations, we can conclude that these two equations are not same. So 1 not equal to 2. So if 1 not equal to 2, you can conclude that the given system is a time varying system. Okay, it's a time varying system. We'll discuss one more problem here again as a discrete time system. In the case of discrete time system, either you can call it as a time invariant, or sometimes they will mention it as a shift invariance. So both are same. And if the signal is discrete time signal, instead of this x of t minus t0, you need to apply an input x of n minus n0, and we need to verify whether the output is y of n minus n0. If both are equal, we can conclude that the given system is time invariant or a shift invariant. Okay. Sometimes in questions they can see the word shift invariance. Check the shift invariance property. So both indicate the same thing: time invariance and shift invariance. Shift invariance is a general term. Okay. The independent variable can be anything like time, space, angle, etc. So that's why they are using the common name in some textbooks, shift invariance. And in the question, it is given y of n is equal to x of 1 by 2n. Okay. Again, a scaled version of the signal. And in step 1, we will apply a shifted version of the signal, or we'll apply a new input x1 of n, which is simply the shifted version of the input signal. If x of n is the input, if x of n be the input, the corresponding output is y of n, which is written as x of 1 by 2n. Now we are applying a shifted version of the input, that is x of n minus n0, means the input portion is shifted by n0 unit. So if you find the corresponding output y1 of n, the equation becomes x1 of n minus n0, sorry, x1 of n. If you apply x1 of n, it becomes x1 of half n. Okay. Now we are applying this particular shift, then it becomes x1 of 1 by 2n minus n0. So make sure that we are applying only a shift in the signal, input signal. That is, we are providing a shift of minus n0. So this is equation number 1. And in step 2, we are writing or we are changing n to n minus n0, because we need the shifted version of the output signal. So in the given equation, we will write in place of n, n minus n0. So it becomes y of n minus n0 is equal to x of 1 by 2. In place of n, we will write n minus n0. So it becomes, if you compare these two equations, we can say that these two equations are not equal. 1 not equal to 2. So the given system is a time varying system. So time invariant property is very important, and you should give some importance when the question is given in or the input signal system representation contain signal part which contains some transformation in the independent variable. Okay. If there is a transformation in independent variable, mostly that system will be in a time varying system. Okay, so always remember this particular terms: x of n by 2, x of 2n, etc. And don't confuse when you are applying the shift operation input signal and the shift operation in the output signal. Okay. If you apply shift operation in input signal, we are simply shifting the by minus n0 unit. And when you are finding the output shifting operation, you need to shift the entire equation y of n minus n0, or we need to replace n with n minus n0. That's a trick actually you can remember. In the input side, in step 1, you can simply shift by minus n0 unit if it is a discrete time system. And in steps 2, you can simply replace n with n minus n0. In most of the case, you can find the you can verify this time invariance property by using this particular method. Okay, thank you.